I think it's one of the most critical aspects of being a data scientist is to visualize what you're actually trying to make sense of. So if somebody gives me a data set which has 1,000,000 rows and 10,000 columns, it's impossible for me to build a model unless I understand what the data means. And you really cannot visualize a 1,000,000 cross 10,000 matrix. That's impossible to do. So you need to do smart things like look at maybe the sufficient statistics of the data to see the trend over time. So to plot it on the x-axis maybe time, on the y-axis maybe some statistics that you're interested in, maybe the mean of the sum of the columns that you think are important. I think domain scientists play a very important role here, so they can tell you, okay, you're given this data set, these are probably important features to look at. So then you go and maybe do some box plots or do some other scatter plots, some trend analysis to see, okay, these are the variables that are important. And then you move to the next step of actually modeling that matrix with respect to your model of choice.
Visualization is very, very important in my day-to-day. Basically, if you have 50 dimensions, there's no way you can look at them, at the numbers of that spreadsheet and make any sense of them. And so visualization basically comes out in pretty much every step of the pipeline design. And for examples are, so if you want to see which features are more important for your model, you'll do some sort of visualization of feature importance. If you want to see the distribution of your data to decide which kind of model you're going to use, so some models make the assumption that the data is Gaussian distributed. You first have to plot your data to see that whether this is true or not. Also to detect the outliers or see definitely that the input to the algorithm is clean enough, because no matter how fancy the algorithm is, if your data is not clean, it's not going to work. So definitely visualization and coming up with new visualizations for this kind of high-dimensional data is very, very important.
Data visualization is very important. I can think of 3 key places where data visualization is very, very important. The first place is in experimentation and exploration of the data. You want to plot your data and make sense of it visually. It's often useful to just look at the distribution of the data, and you might figure out some patterns that you wouldn't have thought about it if you just looked at statistics. Another place that visualization is important is when you are building a model, you want to see how the model performs. You want to also select between a number of models that you have trained. So you basically want to plot metrics, and you look at the metrics and pick. A third place, which is also very important, is when you want to, when you basically deploy the model into production, but you want to monitor its behavior. So you need to be able to detect any anomalies in the behavior of the model, maybe 2 weeks down the line. There might be some trends that you want to detect, and these are things that visualization can be very critical for.
Data visualization is very useful in our work. We use it a lot in A/B test dashboards. One example is we plot daily metrics to monitor the health of a test. Another example is we color the results based on the p-values from statistical testing results. And then, so this makes it easier for people to know whether a test is a win or loss or it's flat.